Yeah. After that, we'll move to talk about slow pump rate or
Okay.
SCR,
SCR,
slow circulating rate, or
circulating rates.
sometimes called reduced rate circulating pressure, RRCP. When we recorded this value during drilling, you know about this
Before,
value?
yeah, before you start drilling, before you drill out.
We recorded normally during drilling operation.
Yes.
Why we need to take this value? What's the meaning for this value first?
This is I can't remember now. Slow circulating rate. This will be your minimum pump rates, right? That you require. Am I right?
Yeah.
To circulate, if you get an influx, this will be the minimum pressure and rate that you will need to circulate the influx out at that depth, at that particular depth. Am I right?
Yeah. Yes. We take this reading during drilling, normal
Yes.
drilling.
Yeah.
We circulate normal circulation from drill string, get the return from the flow line, and we
Right.
start to record this value during drilling operation on
Yes.
the log, and it is reported to the company man with the morning report. Okay,
Yes. Right.
this during drilling operation we used if we got kick. If you got kick and we shut in the well, we'll use this recorded value for circulating out the influx because we
Yes.
need slow pump rate like 30 SPM or 20
Yeah.
SPM to circulate the gas or the kick out from the hole to control
Yeah.
the well and the movement and adjustment for the choke or remote choke.
Yeah.
That's
Yeah.
why if you don't get the kick situation, this only just recorded that.
Yes.
So this one is pump pressure, right?
Yes.
The driller start to record this value. He will start to reduce the pump rate to like 20 or 30 SPM, and they start
Yes.
to take stabilization pressure value. So this
Yes.
value is losses in the system, is affected
Yes.
by the drill string, by bit nozzle, by mud weight. When we
Yes.
should record this value?
When you mean when we should record again?
Yeah, yeah.
If we change the bit, we change the mud weight, change the mud type, or change anything in the BHA.
Yes, because it's related to the pressure loss in the system.
Pressure drop.
First,
Yeah.
we need to record this value near to the bottom. We go of bottom like 1 meter
Yes.
maximum. You
Yes.
slowly
Yes.
your pump rate. Okay. The usually it's take from between 1 to 5 barrel per minute, like from 20 to 50 SPM during drilling.
Yes.
This is the minimum and this is the maximum value to use during killing operation.
Right.
We talk for 2 pump minimum.
Right.
2 reading for 2 pump. Why we need 2 pump to record minimum for 2 pump?
Because you cannot depend on one pump. In case one pump goes offline, you still need the other pump.
Yes, when
during
you
killing
killing
operation,
operation, you have backup pump during the killing operation. And 2 reading
Yes.
also, one is backup to another. If you need to increase or decrease the pump rate during
Yes.
killing operation, you already recorded 2 value. From
Yes.
which gauge you need to record this value? While I am start pump now at 20 or 30 SPM, I have 3 places. One in the driller console cabin, and another gauge in the standby manifold. Third gauge in remote shock panel or SWACO panel, a track flow.
Yeah.
Which gauge?
This should be on the choke panel.
You know about choke panel, right? Track flow.
Yes, because you'll be monitoring the choke panel when you are circulating out the influx.
Yeah. From the same gauge you are using during killing operation, from the remote choke panel or SWACO panel. The difference between the 3 gauge will not be too much, but we need to understand from the same gauge you're monitoring during killing operation. Okay?
Yes.
The same we will do, inshallah, during simulator also. From the remote choke panel.
Yeah, so you take the SCR at the remote choke line, and when you kill also at the remote choke line, right? That's where you're watching the pressure, right? That's the most accurate. Okay.
Yeah, this is more accurate for you.
Yeah.
When we need to take at the beginning for each tour, crew change, I mean here, at least once.
Yep.
At any time, mud propels change like weight or viscosity.
Yep.
When the pit nozzle changes, bottom hole assembly changes.
Yes.
After any repair to mud pump.
Yep.
After killing operation, because it changed the kill mud weight.
Yep.
And at least every 500 feet fast drilling of new hole.
But nobody do this, right?
No, it should be.
It should be, but nobody does, right?
It should be. Why? Because if you drill, for example, fast drilling 500 by 500 by 500, your reading at the kick, it will not the same at the time for the kick. Your reading at while drilling, for example, you are drilling now at 5,000 feet. After 500, you reach to 5,500. You don't take this reading. After you take only at 5,000. After 6,000, you don't take this reading. At 7,000, you take kick. Did you think the value you start to calculate the SCR at the kick depth is the same at the 5,000? It will be increased because the depth is deeper. You go deeper in drilling. That's why every 500 feet to be updated with the value near to the kick situation. Every 500 feet. Because your SCR value will be changed every 500 feet for drilling fast. Okay?
Correct.
Why we need to take the SCR, or why we need to kill the well with a slow pump rate? When you're killing the well, you stop, you already shut in the well by pipe ramp.
Yeah.
You start to circulate from the choke line. It's not from the flow line. So you have limitation in the ID of the pipe.
Yes.
You have limitation in mud gas separator to vent the gas out. You have one operator or supervisor working at the remote choke to control the pressure for the well. So you need all time to control the operation. So we need to reduce your pump rate. First reason, minimize the APL or excess of annulus pressure, which can affect on the bottom for the well. Allow more time to control the choke adjustment. Allow time for the crew to waiting up the mud weight, the kill mud weight density. And also you have gas separator capacity. You don't need to make overload in the mud gas separator. And to reduce the risk for choke erosion, the choke can be erosion from high pump rate. If you get plugging during killing operation, the choke system or choke plug, you reduce the risk for overpressuring the system, which can break the weak point. This is the reason to use slow pump rate during killing operation.
Yes.
Clear?
Clear.
Okay. After that, we'll talk about formation strength test, or some companies called LOT, lack of test, or in some company called FIT, formation integrity test.
Yeah.
What you measure, or what the objective for this test?
The maximum allowable pressure before you have a leak off at the bottom of the hole, with the current mud weight in the hole, to get your maximum allowable mud weight in that section.
Yes, this to get maximum or fracture mud weight. You can drill with next section of open hole. If you exceed this value, you will have losses in the weak point, which usually is the
casing shoe
or casing shoe.
Yeah, correct.
So this one to test the strength for the formation before it start to break or leak. It will not break first, it will leak only. So the leak of test is called leak of test because you have leak start the fluid taking or coming inside the formation. It's not completely break. The difference between leak of test and FIT, formation integrity test, is the same procedure, but in leak of test you make in the exploration well, new area.
Right.
You need to know where, at which point the formation will start to break or leak.
Right.
But in formation integrity test, you perform in development well, known area. So you go up to some safety margin value from surface pressure, and you hold to confirm the formation and show is holding this pressure. Okay, this is the difference between leak of test and formation integrity test. Which pump usually we need to perform this type of test? Rig pump or cement pump?
No, cement pump.
Why cement pump?
Because you can control the pressure accurately. You will not break the formation. You can increase.
Yeah,
because you have more control with cement pump.
It give you more accuracy in data, and second thing, it give you low rate for the pump output with high pressure. You can start with quarter, half, 3/4 barrel, but in the rig pump, it give you from the start for the pump more than 1 barrel.
Correct.
So when you perform this one, after you set your cement, you start to drill out the float show and show track. You drill from 5, maximum 50 feet on the new hole below the show. After that, you will start to circulate to make homogeneous for the mud and the well. After that, you start to pull your string inside your casing before you start your test. Why you need to pull inside the show?
Because you don't want to lose, you don't want to fracture the formation and cause losses with the BHA in the open hole. You might cause differential sticking. So you protect it and bring it back
to avoid the stuck. To avoid the stuck. If you leave your bottom hole assembly an open hole for a long time, it can stuck and you lose the hole.
Correct.
So you pull back to the show. You close your string, you close your BOB, and you start line up your pump or cement unit at the kill line. At that time, you start to pump slowly with no mud weight till surface pressure start to drop. At that moment, you know the formation start to take fluid inside.
Correct.
You stop at this point. This point at the surface pressure is called leak of test pressure. When you add this surface pressure plus your hydrostatic head from surface to the show, it gives you the fracture pressure for the formation.
Yes.
This is the trend. You plot here pressure by volume. When the pressure here start to coming out from the trend, that means the formation will not support this pressure. Start to lose. So at this point, you will stop. For example, this point is 720 psi. When you add 720 psi to hydrostatic pressure in the well, it gives you the maximum pressure at the shore or the breakdown of the formation.
Right.
For example, here, this value at the trend is 720 psi.
Yes.
You have mud weight in the well 9.7 ppg.
Yes.
That show at 3,000 foot.
Yes.
So when you add, can you calculate the hydrostatic head and add to 720?
So 3,000 times 9.6 times 0.052. You get 1498 psi. That is hydrostatic. Hydrostatic is 1498 plus whatever you put on to the cement unit, which is 720. So 1498 plus 720, you get 2218, 2217, 2218 psi.
No, here you need to have correct number without any fraction for the pressure, and this pressure must be rounded down. This is fracture pressure. For
9.6
safety,
times 0.052 times 3,000. You get 1497 plus 720. Yes, 2217.6. So 2217.
2217 because you need to be away, safety margin away from
down. Yes.
The pressure for the fracture. This is
Correct.
the fracture. It's called fracture pressure,
Yes.
or it's called breakdown pressure, or sometimes
yes.
called formation strength PSI.
Yes.
Okay.
Yes.
From this equation, I can divide the two sides by 0.052 by TBD show to get
Yes.
the maximum allowable mud weight or fracture mud weight. The equation for fracture mud weight you will find here in equation number 11 in the formula sheet. Maximum allowable mud density equal to surface leak of test pressure from the gauge divided by show TBD times 0.052 plus leak of test at mud density at the time for the test.
Yes. So you take the total pressure, right? 2217, right?
Yeah, the pressure I will divide it by 0.052. I will divide it by TBD for sure. He give me the equivalent mud weight equivalent to the fracture pressure.
Correct.
This is the equation. Okay.
Yes. So it's 2217 divided by 0.052 times by 3,000 plus our original mud weight 9.6. So we get 2217 divided by 0.052 times by 3,000 plus 9. Wow, that's high. Really?
Yeah. This is calculation, for example.
Yeah. 2217 divided by 3,000 times 0.052. Yes, 14.2.
14.2 here. You calculate here maximum allowable drain flow density or fracture. This must be rounded down. Only one decimal after point mark here.
Correct. So there is two ways, Mr. Hani. You can take the cement unit pressure first, right? And do that plus 9.6, right?
Yeah.
Or you can take the total one and correct. Okay.
The same.
Agree.
Okay.
Yes.
From here, leak of test pressure, usually this is the maximum surface pressure, right? At the outlet. You can see when you add it to hydrostatic head, you will break the weak point. It's the show point. Right?
Yes.
Okay. What parameters can affect the value for the fracture pressure?
What can affect ununiform mud weight? One.
The mud weight from the equation can affect.
Yes.
Okay.
Mud weight. What else? The mud weight. The formation pressure itself.
No, the formation pressure is not factored in.
It's not part of the thing. So what else can it be?
The correct depth for the show TVD. It will affect your value. Homogeneous mud weight in the well first.
Correct.
Second, TVD for the show. Correct depth for the show.
You mean if they place the shoe at the wrong depth? Is that your point?
Yeah, it will affect your value for the fracture or the maximum mud weight.
Yes, correct.
And
if
also,
casing is short.
Yeah, and also calibrated pressure gauge at the surface to read correct surface pressure to calculate your maximum mud weight.
Right.
This is the three parameters can give you incorrect value for your maximum allowable mud weight.
Yes.
Okay.
Yes.
Another definition here related to killing operation is called maximum allowable annulus or annular surface pressure, which is called MASP. M-A-A-S-P.
Correct.
This is also from its name, the maximum pressure you can read at the surface in the annulus. When you add it to hydrostatic head at the show, it will break the show point or the casing show.
Yes. Yes.
So what is the difference between leak of test and the MASP? Post surface pressure, annular plus hydrostatic head, it breaks the show. Look at the equation for the MASP. The MASP equation number 12 at the formula sheet.
Equation number 12. Okay.
MASP equal maximum allowable mud density, which is the fracture mud weight, minus current mud density.
Yes.
All times 0.052 times show TBD.
Yes.
Here, when you calculate for leak of test, you consider in this equation the current mud weight at the time for the test.
Yes.
It can be different from the current mud weight when I took the kick and when I drill in the open hole, right?
Correct.
For example, I start with 10 ppg. Yes. I get from the test maximum allowable mud weight 17.
Yes.
So I start to drill with 12.
Yes.
The mass we calculated based in 12, the time you are drilling the mud with and you take 10. The kick. 12.
Yes.
This is the difference.
Yes.
The mass can be equal the leak of test pressure at the surface if you are drilling with the same mud weight you perform the leak of test with.
At the shoe, yes.
At the shoe. So the leak of test will be equal to the mass. So the mass, this is the maximum surface pressure at the casing. I don't need to exceed during killing operation to not break the casing.
The weak point, yes, correct. This is the point, yeah.
This is the point.
Yes.
Our casing pressure should be less than this value.
Less than the value, yes. So you don't fracture below the casing while trying to kill at the bottom.
Yeah, when you're killing at the bottom. If I exceed, I will take losses inside the shoe point.
The shoe, yes, correct. And you make double problem for everyone, yes.
You will go to something called underground blowout.
Yes.
All the kill fluid, it will be loose in the loose zone.
In the loose zone, yes,
it will be more complicated for killing operation.
More complicated, yes, correct.
If you look here, mass equal maximum allowable mud weight. This is the fracture minus current mud weight. All times 0.052 times TBD for the shoe.
Right, and reference is always at the shoe.
Yes, maximum allowable mud weight and TBD for shoe will not change in the way, right? It will relate it to the formation.
Yes.
What is the parameter can it change to recalculate again the mass value?
Mud weight.
Mud weight. If the mud weight from the surface to the show point it changes, you need to recalculate your mass value.
Correct.
What will happen if the mud weight increase in the well? What will happen to the mass value?
Mass will go down.
Will go down because there is minus here between.
Yes.
When the mud weight increase, the mass go down. When the drilling fluid less, like when the gas coming above the show, your mass will be increased.
Yes.
Okay. So if the mud weight is changed, the mass should be
recalculated.
We calculate first time after shutting the well. And we need to recalculate if your hydrostatic head from surface to show it changed for any reason during circulation.
Yes. So if I'm drilling a head 1,000 meters, 1,000 feet below the shoe, and I change the mud weight, I should recalculate the mass, right?
You will recalculate.
And I should lock that again. So in case we take a kick below the shoe, we shut in the maximum will be based on the new mud weight, right?
Yes, for sure.
Yes.
Yeah. This is the mass value. When I need to consider our casing pressure will not exceed the mass. Only when you circulate the gas kick from inside the open hole, from the bottom up to the show point.
Yes.
After that, we will not consider the mass value.
Correct.
will not. Why? Because when the gas kick out from the show, the show point or casing show pressure will be constant, will not break.
Yes. Correct.
Okay.
Correct.
Here, if you look with another way, mass equal to maximum show pressure, the fracture pressure, minus bottom pH at the show. If the pH is down, I mean here the mud weight, the parameter, the mass will go up. If the pH mud weight increase, the mass will go down. One is looking up for mass when the show pressure is down. Mass is down when the show pressure or hydrostatic head of the show is up. This is the relation between the mass and show pressure.
Yeah.
Okay. And mass also, when you round it, it will be rounded down, like the fracture pressure, like LOT, leak of test. Why? Because this is maximum value. If I exceed, I will break.
Yes.
I need to be away from this value.
Away from the maximum, yes.
Yeah. What parameters can increase the risk of exceeding mass?
What can increase the risk of exceeding mass? Can risk of exceeding mass?
Incorrect.
Depth. Yeah.
Unexpected high pressure, kick size.
Yes.
If you take more kick volume, that means height will be more reduction hydrostatic head. So the casing pressure more increase. So the range between the casing pressure and mass will be less. The margin. Low fracture pressure formation.
Yes.
Long open hole section. That means you need to circulate long distance from bottom to the show to control your casing pressure away from the mass. If you have gas migration in closed well, all pressure will be increased. Bad practice during killing operation. You put too much safety margin during killing operation. You are near from the mass. Ignore choke line friction. This is for subsea. Usually in surface BOB, we ignore the choke line friction because it's short length. But in the subsea rig, it will be short from seabed up to surface.
Seabed to top surface, correct.
Okay.
Correct.
This is the parameters can increase the risk for exceeding the mass. If you exceed the mass, you don't need to exceed mass value during killing operation. When you kick in the open hole section from bottom to the show. After show, if the gas is out from the show, you will not consider the mass value. Okay?
Yes.
When we deal in this course with the kick, we will consider the scenario, which is the worst scenario. Our calculation will be based on gas kick. It's not oil or water. Why? Because the gas has different behavior from the liquid.
Yes.
The liquid, when you take temporary kick at the bottom, the temporary will come to the surface like the same temporary, water or oil.
Correct.
But when you take temporary, for example, equivalent to increase in the tank gas, the gas will start to migrate in closed well with the same pressure for the formation.
Correct.
It can exceed mass quickly, or while circulating, it will start to expand according to Boyle law for expansion for the gas. So it will take height in the more height inside the well, more reduction hydrostatic, more increase in the surface pressure. That's why dealing with the gas is the worst scenario. But dealing with gas and oil, it will be less risk. So in our assumption in this course and our calculation will be based on
gas kick
on the bottom. Now we take kick, so we have positive indicators. and we start to shut in the well. This is the procedure now. We transfer from principle to the procedure for shut in. What the driller should do, the driller is responsibility to indicate the kick and react fast to shut in the well without any delay, without any permission. What is the type or procedure for shut in? You know about hard shut in procedure and soft shut in?
I've read about it, but not too sure.
Okay.
Hard shut in is all about timing, right?
Yeah. You have two types for shut in. Most of companies dealing with hard shut in or soft shut in. This is the decision for the client. The client policy said that you need hard shut in procedure, so the rig will follow this instruction.
Right.
Okay, for the line up during any operation. For the hard shut in procedure, if you look here, you have your BOB stack, annular, blind shear, pipe ram, and lower pipe ram of the wellhead. You have kill line here, and you have choke line here.
Right.
Here you have cement unit, and you have mud pump.
Right.
The red is closed, and the green is open. This is the line up during tripping from the start spot to the end for the well.
Right.
Here in each choke line and kill line, there is two valves. One is manual, and one is called HCR, hydraulic valve.
Right.
7 and 8, this is manual valve. You can close by hand. Usually we kept open. We don't use during killing operation.
Right.
And
it's left open, right?
Kept open all the time.
Yeah, it's left open. Yeah.
Okay. And this is in the side for the BOB body. And the outer is the HCR valve, 6 and 9. Usually we kept closed. Why we kept closed during drilling? To take the return from the flow line, from up. Okay?
Yes, correct.
And here we line up to mud pump. So we pump from the string, we get return from the flow line. During killing operation, we close the pipe ram so the kill and the killing operation will be coming through the choke line. From the choke line back to the choke manifold. Arrangement for valves to control the pressure for the well. 10 is open, and this gauge is open. The manual gauge, the manual valve 11 open, and the remote choke is completely closed.
Closed.
This is the line up for hard shut in.
Yeah.
HCR closed. Remote choke is closed from beginning. Completely closed. How you close? There is lever on the remote choke panel to keep the choke completely closed. If you need to check, you go to rig floor to check this line up. If the rig is follow the correct procedure, that means we follow the procedure for well control. Any deviation from this procedure, it will be a big problem. Okay.
Yes.
So the only change or difference between hard and soft, hard from its name is hard way. So the remote choke from the beginning is completely shut. But if you look, now we are drilling and we had hard shut-in procedure. What I should do if I take kick during drilling operation? I'm drilling on the bottom. The increase in the flow rate coming and the flow line. So I stop bump and I need to shut in the well following hard shut-in procedure. What you should do first, you will pick up of bottom from the bottom and position string. You have the tool joint above your rig floor. You can see why to close the BOB.
You space out to avoid the across the tool joint.
Second point in sequence, you stop bump and rotation.
Right.
Third, it is hard. So you start to close immediately the BOB, whatever RAM or annular. It's up to you.
Right.
So there is sudden impact now on the formation.
Right.
This one is closed and the BOB is closed.
Yeah.
After that, you will open number 9, open hydraulic side outlet valve. So the flow or the pressure will come from this side, coming here, hit the closed remote choke, and you start to read shut-in casing pressure.
Yeah.
The annulus pressure.
Yeah.
This can manage this procedure with hard formation.
Yeah.
What mean hard formation?
Strong
formation, the strength is high to not break immediately. If you use this method with soft formation, it will break because suddenly you close the well on the kick.
Correct.
That's why it's hard shut-in procedure.
Understood. Mr. Hani, this RAM or annular, who makes the decision on whether you close the RAM or the annular?
It's up to you. It's up to you. The well control is not specify the RAM or annular. If you need to start with annular, it's okay. If you need to start with pipe RAM, it is okay also. The rig make decision. If you are drilling with Kelly, you know the Kelly? Some rig is Kelly rig. So at that time you close the annular. The pipe RAM will not seal around the Kelly. Okay? This depends on the operation.
Right.
So what about line up for soft shut-in? All same except the remote choke is completely open.
It's completely open,
from the beginning. That's why it's called easy and soft way to shut in the well. So what is the procedure if I need to close while drilling the well if I get kicked? First, the same pickup and position string space out. Stop pump and rotation. Third thing, I will not close the PUP. I will give pass for the flow. I will open the HCR. So the flow coming from the BOB and coming from the choke line. After that, I will close the BOB. Number 4. Still have influx or flow coming through the open remote choke. After that, finally, I will start to close remote hydraulic choke and I recorded the casing pressure.
Understood. So you leave time for the fluid to flow out first to reduce the bottom hole pressure, and then the final one is the remote choke. So you're not banging the bottom of the formation, right? That's the point, right? Yeah.
This method is suitable with the soft formation or weak formation.
Or weak shoe, yeah.
That's why in the same country you can find one field use soft and another field use hard. This is the client decision.
Understood, Mr. Hari.
Which method give you less volume for the kick?
The first one.
Hard shut in, because from beginning you shut in all the way.
Yeah, correct.
The increase in the tank will be at the time you notice the kick. Before you shut in the well. But here you give pass, so you will take a lot of kick volume and soft shut-in procedure.
Yes.
Okay.
Correct.
I have a question here.
Yes.
Can I replace number 2 by number 1, step number 2 by step number 1? I start to stop pump and rotation first, then I make space out.
Stop pump and rotation first, and then pick up off bottom and position string. Stop pumps and rotation. Stop pump and rotation. You can stop pump and rotation.
Do you have any effect?
You might stick the you might if you don't pick off bottom, you might stick the BHA down in the hole. It can happen, right? Stop pump and rotation. Pick up. Stop pump and rotation. And then pick off, pick up, stop pump. You can. Why not?
No effect.
The kick will probably, it will not migrate so fast up the hole if you stop the pump first, right?
Why?
Because you stop the pump, so that you're not pumping the kick up. The kick will be lower down if you stop the pump and then pick off bottom. But you might get stuck also.
What you lose if you stop the pump first?
You will lose your hydrostat, your APL, your ECD.
You will lose APL.
Yes.
What will happen if you lose the APL? You lose more pressure control the formation, right? From beginning. That
yes,
means
you
if you
introduce more influx, really.
yes. If you stop the pump from the beginning,
yes,
you will have more influx inside the well compared to if you space out first, then you stop the pump. That's why I need the pump running with me till the moment I will shut in the well.
Shut the well, yes.
To have more pressure on the zone or the formation, to have less influx volume.
Yes.
Because space out and offshore sometimes take 1 minute. Imagine if you increase your kick volume by 2 barrels, and this is gas. The gas start to reach to the surface, the 2 barrel, maybe it's come to the surface like 15 barrel or 20 barrel.
Yes.
So there is effect. That's why you will pick up first, then you stop your pump and rotation.
Right.
To
so
keep
APL. Last, huh?
Yeah.
To keep the APL and the ECD the same at bottom hole. Understood. Understood.
After that, you shut in the well. What will happen? The well start to stabilize. The pressure at the surface start to increase to reach shut in the drill pipe pressure and shut in casing pressure. So after that, you convert the pressure to more value in the mud weight to kill the well. Before you start to read the value at the gauges, you need to make sure there is no leak while shut in the well from the BOB. So this is the first action the driller is responsible for. The driller now shut in the well without any delay. He will pick up phone to call the tool pusher and the company man to rig floor. I have kicked, I shut in the well already. Come to rig floor. So before start to take reading, you need to make verification about the closed BOB.
Yes.
The best way here to line up above the closed BOB on the trip tank. If you have any leak, you will see in the trip tank. You will see droplet in the trip tank. Why trip tank? Because small tank in the volume.
Yes, correct.
By this way, you are sure your reading for the pressure will be correct. If you have leak and you take reading, your reading will not correct. Your calculation for kill mud will not correct. Finally, you will not be able to kill the well.
Yes.
Or sometime the driller will visually check the BOB from outside and coming on rig floor and start to check from the bin nipple, from rig floor from above with light or torch light. And line up to the trip tank and set the alarm and sensors. So if you have increased that indicate you need to close another ramp to stop this leak. This is how to verify you are successfully shut in the well. After you shut in the well, you start to record your value for shut in drill pipe pressure, shut in casing pressure. And this is the responsibility now for the supervisor. To start to complete the kill sheet and to calculate kill mud weight and to make plan for killing operation. Clear?
Clear.
Do you have any question at this point?
Mr. Can you go back to the hard shut-in procedure?
Here?
Yeah. Okay. This number 6 will never be open. Huh? Once you shut in number 6, you don't have to open that valve.
Which one? Number
Number
6?
6.
No, number 6. This is kill line.
So these ones are closed. It's nothing. That is only the second stage only. Yeah. So right now it's all just through the remote choke. That's it.
Yeah,
okay.
Yeah.
Okay.
This is connected to pump with a check valve.
Yes.
Here.
Yes.
Okay.
Yes. Correct.
Here it is check valve.
Correct. Yeah.
And this is again look at soft shut-in.
Same.
The first two steps is same.
Yes.
Okay. Any question? We'll stop for lunch break.
Yes. No question.
Okay. After
no
inshallah half hour, see you. Okay.
Sure. Thanks, Ridani.
Thanks. Here our presentation. Last point we stopped at after we shut in the well and verification that the closed BOB is not, there is no leak from the BOB. So we now are going now to record our shut-in drill pipe pressure and shut-in casing pressure. Pulse gauge will start to increase till stabilization happen to the bottom hole pressure. Bottom hole pressure will be equal our formation pressure.
Yes.
In this case, we start to take our reading every 2 minutes. We'll start to record time versus the shut-in drill pipe pressure and shut-in casing pressure. Usually, when the influx coming inside the well bore, it will enter the annulus area. It will not affect inside the drill pipe. Why? Because you have float valve in the string.
Yes.
And if you don't have float valve, also the nozzle for the pit will not allow the kick to coming inside the drill string. So the drill string will be homogeneous fluid, the drilling mud. So here, if you look here, surface pressure and time after shut-in, you will have annulus pressure higher than the drill pipe pressure. This is initial build up.
Yes.
Okay, after that, there is a stabilization period. From in this period, you will start to take your reading, shut-in drill pipe pressure and shut-in casing pressure to start your calculation for killing operation. After some time, while you are working in the kill sheet and calculation, you will start to see all pressure in the well start to increase by the same amount for delta B, for the pressure increasing. This due to influx is gas, and the gas start to migrate due to its density, different density between the gas and drill fluid inside the annulus.
Yes.
What the data you will record? Shut-in drill pipe pressure, shut-in casing pressure, and bit gain. This increase in the level inside the tank at surface equivalent to the volume of the cake inside the well bore. Here, the yellow is the gas outside the drill string, and the drill string is clean of drill fluid. What is the shut-in drill pipe pressure refer to? The difference between bottom hole or formation pressure and the hydrostatic head inside the drill string.
Yes.
Shut-in casing pressure give you difference between shut-in bottom hole pressure and two hydrostatic head in annulus, hydrostatic head for influx, plus hydrostatic head for the mud. Bit gain give you indication about the influx at shut-in. At normal condition, shut-in casing pressure higher than the shut-in drill pipe pressure. Why?
Yes. Shut-in casing pressure higher than shut-in drill pipe pressure. Yeah, because the influx is in the annulus.
The influx in the annulus give you
more pressure.
less in hydrostatic head. To compensate this reduction, casing pressure will increase and jump this, compensate this difference to have bottom hole pressure equal to the formation pressure.
Yes.
Okay.
So it means the kick is already inside the casing.
Yeah. It's affect the casing pressure only. That's why we tell you from beginning, if you shut in the well in small volume for kick without any delay, you will get less shut-in surface casing pressure here, So you have range away from the mass value. So your
Yes.
killing operation will be more easy.
Yes.
Okay, let's look here. This is the drill string area part.
Right.
This is the annulus area. So
Right.
when the well is shot in, formation pressure, it will be equal bottom hole pressure from both sides.
Yes.
From the drill string side, formation pressure, it will be equal shot in drill pipe pressure plus hydrostatic pressure of mud inside the pipe. Shot in casing pressure other side plus hydrostatic for influx plus mud hydrostatic, it will be equal formation pressure. So which side is the best to calculate your formation pressure? It will be the formation side, the drill pipe string side, because it's clean fluid. So you
Yes.
get the surface pressure, you get hydrostatic head, you calculate your formation
Yes.
pressure. After that, you can move
Yes.
to the other side, your formation pressure known, so you can know the gradient or the type for the influx inside the well bore.
Yes. Yes.
Why shot in casing pressure higher than shot in drill pipe pressure? Because hydrostatic pressure or hydrostatic head annulus is affected by the influx.
Influx. Yeah.
Yeah. What can affect how if we have float valve in the string? What
Yes.
you will read at the surface?
If you have float valve in the string, if you have.
Yeah, and you have kick. You will read only shot in casing pressure. The shot in drill
Yes.
pipe pressure will be equal 0 because when you shut down the pump, the float will
Yes.
close.
Correct.
So how we can record shot in drill pipe pressure in this case?
Can you use? Can you? No, you cannot use the pressure before you shut down. You can use slow circulation rates.
You
No.
will open the float valve to read the pressure. So you use the pump for sure. How we can
Yes.
know, how we can do this here, how to can find shot in drill pipe pressure. You have casing pressure value 600 psi and shot in
Yes.
drill pipe pressure 0 and you have float valve
Yes.
here. 0 shot in
Yes.
drill pipe pressure. So you will
Yeah.
start your pump slowly, 5 only
Yeah.
SPM, like half barrel.
Yeah.
And you
Yeah.
look at the shot in casing pressure value. When you see the shot
Yeah.
in casing pressure start to increase, that means there is communication
Right.
and the float valve is open. At this moment, you shut down your
Yes.
pump, you read the trapped pressure inside the drill string, which is shot in drill pipe pressure value.
Drill pipe pressure. Yeah.
So here, pump slowly down the
Mm.
drill pipe 5 SPM and watch build up in the annulus. Correct shot in drill pipe pressure as soon as shot in casing pressure start to increase. If you look at this figure, here the casing pressure start to increase little bit like 20 or 30 psi. At this moment, we read the shot in drill pipe pressure 500 psi. Because any increase in shot in casing pressure, it will have the same increase in the shot in drill pipe pressure value also. Because
Yes.
this is
Correct.
closed system.
Yes.
If you forget, and this one is 700 psi jumped up 100 psi,
Yeah.
so your reading
Yeah.
shot in drill pipe pressure will be more than also 100 psi. Instead of
Yes.
500, it should be 400 psi.
Yes.
Accurate reading for shot in drill pipe pressure, you will convert to kill mud weight, this value. So if
Yes.
you cannot read shot in drill pipe pressure correctly, you cannot get data about formation pressure value, you cannot
Yes.
calculate your kill mud weight, you cannot kill the weight.
Yes.
So kill mud density, the equation number 13 in formula sheet, look at this one, this equation. Kill mud
Number 15.
density, it will
Yes.
be equal shot in drill pipe pressure divided
Right.
by TVD for the well times 0.052 plus the original or the current mud weight in the well. So you convert the surface pressure and added this value to the original mud weight to have kill mud weight. In this case, the kill mud weight is equivalent to the formation pressure without any safety margin overbalance. You should add some safety margin to be overbalance the formation pressure.
Yep.
Okay. So the formation pressure or the value for shot and drill pipe pressure will not have any effect with the influx height or influx volume. Only the casing pressure have effect by the influx height or influx volume or kick volume. Okay?
Understood.
Here we talk about pressure stabilization. You remember when you talk about permeability, here you can see the effect for the permeability. At the same depth, if you have high permeable zone and low permeable zone, which one it give you more influx volume?
High permeability.
High permeability. So which one will give you higher surface casing pressure?
High. The influx will be faster, and then it will stabilize faster also, the high permeability.
So the high permeability here, for example, 900 psi casing pressure. But low permeability, because low influx volume, it give you less, like 700 psi.
Correct.
Here, the stabilization, it will be fast. And slow build up. So that's why detect kick or stabilization after the kick for the pressure reading will be more difficult when you deal with low permeable or low permeability zone. This is the first point will bring complication in reading for the surface pressure. You need to wait more for stabilization.
Yes, correct.
Let's think together about these conditions. First case, you have reading for shut-in casing pressure and your shut-in drill pipe pressure equals 0. In which case?
Your float is closed.
The float is closed. You have float valve in the string. What also? Or what else?
Casing there is pressure, but drill pipe there is no pressure.
Yeah, 0.
Is it? Okay, so casing there is pressure.
Casing is reading, has a reading, no problem.
Okay, casing has a reading. One is float valve is closed. Number 2. If your nozzles are plugged, maybe.
Nozzle is plugged completely.
Possible.
You cannot have
0
this.
psi on the SIDPP.
Yeah, but this is very difficult because which one? Gauge.
No, it can be plugged. It can float valve not open.
Gauge problem.
Gauge not working.
Yes.
And gauge problem and nozzle plug.
Yeah.
Nozzle plug maybe not easy, but gauge not working, yes, possible.
Yeah, you have blockage in the drill string, like this block. In second condition, you have reading in shut-in drill pipe pressure, no problem, and shut-in casing pressure 0 from the beginning. We didn't at the moment you shut in the well.
The gauge not reading properly. Problem with the gauge.
Okay.
Problem with the gauge, and what else? The kick is not migrating enough, or very no.
What means the kick is not migrating?
So you're not getting pressure reading.
You have backed off around bottom hole assembly.
Or the kick is dissolved in the mud. The gas is dissolved in the mud.
No, but you should have reading. It's not completely dissolved.
The casing pressure valve is plugged.
Also, you can have gauge problem, or you have back off around the bottom hole assembly. So the influx is below.
Zero, it cannot be zero, right?
Completely back off, it will give you zero because the influx is below.
Sorry, again, please.
Back off. There is back off. The formation is backed off around your string or bottom hole assembly. So the influx will not affect that. There is no reading in the casing pressure.
Okay. You mean to say, okay, back off, yes.
Okay.
The influx is below the back off, okay.
And what also?
Right.
If you have bad line up for your BOB stack, you close bottom pipe ram instead of the upper pipe ram. So your choke line is above, is not have any reading for shutting casing pressure. When you close, you should close the upper pipe ram, so the choke line is below. When you open, you will have reading.
Yes.
But if you close the bottom pipe ram, you will not be able to read shutting casing pressure from beginning.
Yes, correct.
Okay. In which case, shutting drill pipe pressure equals shutting casing pressure at the time we shut in the well.
When you shut in the well, there is no float. The float is open.
Both will be same.
If the kick is if the kick is already moved above the drill bit, then no, it's not.
It's not, because annulus area, the height is B less, so you need to have the same height inside the pipe and the annulus.
Yes.
And this is impossible.
Yeah. No, I don't know. I don't know why. SIPP, SIDPP, and SSCP. In what case will it be the same?
If your influx weight nearly equal to your water bismuth, if your kick influx is water and its weight is near to your drilling fluid density.
Okay. So you will not see any difference in SIPP and SIDPP and SSCP. Okay.
Yeah. This is first point. Second point, in horizontal well, if you are drilling horizontal well and your influx in the horizontal section, there is no vertical length for the influx. So both will be nearly equal from the beginning till the influx is coming out from the indeviated section.
Yes, correct.
Right?
Correct. Right.
Correct. And also, if your string is off bottom, your string, you are tripping out and the influx is below your string. So hydrostatic head outside and inside the drill string will be same. So shutting drill pipe pressure will be equal shutting casing pressure.
Yes.
And after first circulation of driller method, when the gas is out from the well, the same casing will be equal the shutting drill pipe pressure.
Yes, correct. Correct.
Okay. Look here, what is the difference here?
No cuttings in the annulus, so your casing pressure is higher than your drill pipe pressure. And the second one, annular little bit cuttings.
In which case you get higher annulus pressure?
Yeah, the hydrostatic is because of the cutting also in the casing in the annulus. Sorry, Ms. Hani again?
Yeah, sorry. Sorry, the communication is down, I think.
Yeah.
Again, I will share the presentation.
Yeah.
You can see the presentation now, right?
Yes.
Okay. In which case you will get higher shutting casing pressure.
In the first case and the second case with the annulus loaded.
Was the annulus loaded?
Oh, no. Sorry. In the first case, you will get higher casing pressure than the second case.
In the clean annulus, you will get higher casing pressure.
Annulus.
Why?
Yes,
because the cutting loading will make higher in hydrostatic head. So the casing pressure will be dropped, so the summation will be equal constant bottom hole pressure or formation pressure.
Yes.
Okay? This is here the difference. The drill pipe pressure will have no change here because this is the difference between formation pressure and hydrostatic head, which is not.
Yes.
Okay? This is of bottom, the case where shutting casing pressure equals shutting drill pipe pressure.
Yes.
Your influx is below the pit, so the circulation point, hydrostatic head and annulus equal to the drill string.
Right.
So both is equal. Once you start to stripping back to bottom to clean the well from the bottom, after the bottom wall assembly coming around the influx, so the casing pressure start to increase to the its normal value when you are on bottom.
Yes.
Here the back off.
Yes.
If you have back off around bottom wall assembly and the influx is below, no flow at the annulus. So zero and shut and drill pipe pressure has reading.
Yes.
Here, what this one? Shut in horizontal well. No hydrostatic head vertical for the influx. So both will be equal from the beginning. Till the influx start to coming in deviated and vertical section.
Then you will see.
Then you see increase in shutting casing pressure.
Yeah.
Now we'll talk about the gas behavior.
Yes.
The gas is different in behavior than the liquid, oil, or water. That's why it is the worst scenario for kick during the killing operation.
Yes.
You have two behavior for the gas. First one is called gas migration. It's coming from migrate. That means this happen in closed well, in closed system. The well is not open from the choke, so the gas start to migrate inside the well with its pressure. What is the pressure for gas bubble at that time in the bottom?
5,500 psi.
It will be equal to the formation pressure coming from.
Yes.
Right? So imagine the effect for gas migration if we don't take action. The gas start to migrate with its bubbles for the pressure, for the bubble. So the formation pressure will start to coming inside the well pour. That means you will break the weak point or the show, casing show at quick time if you don't take any action. This is the gas migration. Gas is lighter than the mud and will try to migrate up the hole.
Yes.
And if you look here from left to right, when you close the well, you have shut-in pressure 500 psi. Bottom hole pressure is equal to formation pressure after stabilization, 5,500. Bubble pressure or gas influx 5,500 psi. Hydrostatic head in the well equal 5,000 psi was the mark. Okay.
Yes.
We have here some assumption for this calculation or this illustration. We assume first the well is vertical well.
Yes.
Okay. Second, we assume when the gas is coming inside the well pour, it coming as one big bubble.
Yes.
It's not separated bubbles as actual. To be easy for us. We assume also we ignore the compressibility for the fluid and we ignore temperature effect inside the well pour. Okay? And also we consider The drilling fluid is water-based mud because in
Yes.
oil-based mud there is solubility for the
Yes.
gas inside the oil-based mud. So the calculation, it will not be easy like water-based mud.
Yes.
Okay, so let's look here. 5,500 psi. If you keep the well is closed without any action and you start to calculate your kill mud and make plan, and the gas migrate inside closed well and reach to the casing shore in the middle for the well. Here, when the bubble is coming up, it will be considered as a solid substance. It will not affect by pressure above and below.
Yes.
So it will be reference inside the well bore. So
Yes.
the bottom hole pressure, it will be equal to 5,500 plus 2,500 psi.
Yes.
It will increase to 8,000 psi.
Yes.
From in the surface pressure, it will be 5,500 minus
Yes.
2,500. It will be 3,000 psi.
Yes.
How much increasing in the value for shut-in casing pressure here between two stages? How much increasing?
2,500.
And how much increasing bottom hole pressure?
2,500.
That means each point in the well will increase by the same amount for the pressure.
Yes.
Why? Is because it is closed well.
Yes.
Show pressure, casing, drill pipe, and all
Yes.
point will increase by the same amount or gas migration.
Correct.
If you back again to this slide here, we said
Yes.
all point will start to jump up with the same amount because gas
Same
start
rate.
to migrate.
Yeah. Yes.
Okay. Here the gas is reached to the surface. So bubble pressure
Yes.
coming to the surface was 5,500.
Yes.
So surface pressure will be
Yes.
equal. This is the maximum pressure
Yes.
reading, 5,500. And
Correct.
bottom hole pressure will be equal 5,500 plus 5,000
Plus
hydrostatic,
Yes.
10,500 psi.
10,500. Yes.
So how much increasing in bottom hole pressure?
From the original 5,000 psi.
It is increased 2 times bottom hole pressure, right? And surface pressure?
Yeah, 10 times.
10 times. You imagine the risk for gas migration now?
Yes.
This is the problem for gas migration because
Correct.
the gas with its pressure will raise up inside the well.
Yes.
Okay, the speed for gas migration will be based on what? Based on mud properties, weight and viscosity, and hole angle inclination. If you have high angle well, the gas migration will be slow. In vertical well, it will be fast. And the rule of thumb, gas migration maximum, according to the experience, ranged from 500 foot per hour, maximum 1,000 foot per hour. The gas migration. It is depend on hole angle and mud properties, but it's range minimum 500 up to 1,000 foot per hour. That means if you have closed well 10,000 foot, the gas can reach to the surface in 10 hours.
10 hours. It's very fast.
Yeah. So the gas cannot expand. So it will carry formation pressure upward, causing shut-in casing pressure, bottom hole pressure, shut-in drill pipe pressure to increase. If you exceed the mass, you will risk to break weak point, which is the casing shoe.
Casing shoe.
Okay.
Yeah.
There is one equation regarding to the gas migration rate in the formula sheet.
Yes.
And there is one question can come in the exam about this calculation. Number 17, gas migration rate. This equation apply only for water-based mud. Okay.
Right.
Equal to rate of increase in surface pressure, whatever is shut-in drill pipe pressure or shut-in casing pressure, divided by the drilling density by 0.052. The gradient for the mud. It gives you how many feet per hour the gas start to migrate.
Yeah, but this one you need to monitor the well first, so you will know the rate of increase in surface pressure, right?
Yeah,
in the
you
1
will,
hour. Yeah.
after
You
the
will know.
stabilization period,
Yes.
you start to record the pressure. When you start to read, for example, the casing pressure 700 and drill pipe 500, you will see 550, 750.
Right.
So you need, after the 600, 800. So you know the increasing now is 50 psi. You take the 50 psi and apply this equation to give you approximate the gas migration speed, how much.
Yes, understood.
Okay.
Okay.
Here, gas migration, how to deal with. We need to bleed some pressure from the surface.
Yes.
Okay. While keeping bottom hole pressure constant to not take additional
more influx. Yeah.
And you bleed some mud to give space for the gas to expand.
Yes.
Expanding gas is better than migration for the gas. Why?
Yes. Pressure is lower.
Because pressure will be less in the bubble and the volume will be increased.
Yes.
So in this way, we control the gas migration.
Yes.
Instead of it is coming out inside the well without any control. So here, if you look, drill pipe pressure 500.
Yes.
It is increased to 600 due to gas migration.
Yes.
So we bleed some mud. While bleeding the mud here, we bleed and keep shut-in drill pipe pressure constant. Why? To keep bottom hole pressure constant, because this one is homogeneous phase. Usually, we keep the homogeneous side is static. Why? Because the casing pressure will be jump up, because more expansion, more reduction hydrostatic. To compensate this reduction, casing pressure will increase. So the summation will be constant number equal bottom hole pressure. This is how to deal with gas migration while prepare your kill fluid density to kill the well, if you will wait for some time. Bleed some mud, allowing the gas to migrate or expand in constant way, while holding shut-in drill pipe pressure constant. Okay?
Yes.
The another behavior is called gas expansion. Here, we open the well. We're manipulating the choke, open and close, while killing operation. So instead of gas migrate in closed system, no. The gas start to expand, its bubble pressure decrease, its volume increase, so the gas start to expand. Where the maximum expansion for the gas at the surface during killing operation? A maximum expansion for the gas. In which place?
At the
surface. So this is the maximum casing pressure you can see at that choke, right?
Correct.
Because maximum reduction hydrostatic head, and to control bottom hole pressure above formation pressure equal, so the summation will be less, it will be same. So when your hydrostatic head become less, you close the choke more, so increase surface pressure. So summation for surface pressure plus hydrostatic is equal to bottom hole pressure, at least equal your formation pressure, to prevent excess influx to coming inside the well bore. This is the target or objective for well control method. Getting gas or influx out without getting additional influx inside the well bore. How to control? By hydrostatic head and surface pressure, both is equal to bottom hole pressure. So what will happen to the gas volume? Gas volume increase while expansion, and its pressure bubbles will be decreased.
Yep.
Maximum expansion will be near to the surface.
Yep.
Gas pressure increase while the gas expand due to loss in hydrostatic. What will happen to the bit gain at the surface, the tanks? It will be increased because
Yep.
the gas expansion will push more mud ahead.
Out.
That's
Yes.
why we said we need to monitor the
Bit gain.
level for the tank
Yes.
for loss or for gas expansion.
Yeah.
After the gas as the choke, so the gas start to coming out, so the bit gain start to decrease. You will compensate the gas out with mud. After
Yes.
completely gas out, the level for tank will be static.
Yes.
If you don't have any loss or loss.
Yes.
After gas is out, pit level become steady. This is the behavior for gas expansion. So the gas
Yes.
expansion increase casing pressure, but with controlled way, better than the gas migration inside closed well. The gas expansion here will follow the Boyle law, P1 V1 equal
Yes.
constant, or P1 V1 equal P2
V2,
V2.
V2.
Pressure by volume for gas equal at point 1 equal pressure by volume at another point or at the surface. This
Right.
gas law, you will find equation number 18 in the formula sheet.
Number 18. Okay. Okay. Yes. Gas loss. Okay.
Okay. Here is the figure to describe the gas expansion open hole, volume 1, double,
Mm-hmm.
4 time.
Yes.
So the pressure will drop 8, 16, 32.
Yes.
Maximum expansion at the surface, so maximum bit gain at the surface here.
Yes.
Okay. The gas when start to expand, any pressure point above the gas will start to increase its pressure. Like when the gas start to expand, casing pressure at the surface start to increase. Maximum increasing when the gas start to reach to the choke or to the surface. Any point the gas passed, finish, it will be constant. Any point below the gas, it
Yeah.
will be constant
Yeah.
its pressure. Any
Yeah.
point gas start to passes, the pressure start to drop.
Yes.
Let's take example for casing show. When the casing show or the show pressure will be the maximum value, in which case, while killing operation, show pressure.
Shoe pressure will be highest when the gas is at the surface.
No, show, the show point, not the casing pressure.
Okay, hold on. Gas expands and signal up the hole.
Yeah.
At any point above gas. Okay, when the gas is at the bottom of the hole, below the shoe.
When the gas bubble top for the
Below.
gas is reached to the show point. Maximum
That'll be
expansion in open hole.
when the gas is at the shoe point, the shoe point will be the highest.
Yeah, because when the top for the gas reaches to the show, this is the
Right.
maximum expansion for the gas in open hole.
Right.
So maximum increasing as the show pressure.
So the each point will see the highest pressure when the gas is at that point. Is it? Is that the point?
Again.
That means each at any point.
Show.
Yeah.
Here.
Yeah.
Pressure.
Yeah.
Will be equal from bottom. Will be equal bottom hole pressure.
Right.
Plus B hydrostatic.
Yes.
An open hole. right?
Yes.
From the bottom
Correct.
for the well, imagine that the show pressure is the top point, right?
Right.
So show pressure, it will be equal bottom hole pressure plus
Yes.
hydrostatic head for open hole.
Yes.
Bottom hole pressure equal formation pressure.
Yes.
Constant number, for example, 12,000 psi.
Okay.
2,000 psi, sorry.
Okay.
Show pressure, it will be maximum when this one it become more or less the lowest value, right?
Right. Right.
So the summation, it will be same.
Yes.
When this value, it will be lowest value, be hydrostatic and open hole. When the gas take maximum expansion open hole, maximum head, so maximum reduction in pressure hydrostatic and open hole. So the show pressure will be maximum value during this circulation.
Yes. Yes.
Right?
Yes.
Okay. What will happen when the gas start to coming passes? That means now some is left and some is still in open hole. What will happen to the hydrostatic head in open hole? It
will reduce.
will start to increase because some gas is out and the mud compensate this gas. Right?
Okay. Right.
So here hydrostatic and open hole will become to increase, right? So what we'll see for the show pressure will start to drop.
Right.
Both
Right.
will be equal to 2,000 psi, as we said, for example.
Yes. Yes.
So this point give you illustration about this point. Pressure at any point above the gas will start to increase or increasing. And gas, when it passes, pressure will start to drop, like what happened in the show pressure. When the gas out from the show pressure, it will be constant. Why?
Yes.
Now the bottom hole pressure constant and P hydrostatic and open hole is have mud. It will not change because the gas above the show. So the show pressure will not change.
Yeah.
That's why we consider our casing pressure not exceed mass only when we circulate the open hole section.
Right.
Because after open hole section, we will not consider for the mass. Why?
Correct.
Because the show pressure, it will be constant.
Yeah, so we don't care anymore. Yeah. Once the gas is in the casing, we don't care about the show anymore, right?
We don't care about the show or mass value. And the mass value will change now because the gas start to enter the show.
Yes.
Reduce the hydrostatic head. So what will happen to the recalculate mass? It will be higher or less when the gas is coming inside the shoe.
The gas coming inside the shoe, so you will displace more mud in the hole, right? So the mass will come down.
Again.
Mass will go up.
Why? Because gas affect the hydrostatic head above the shoe.
Yes.
It will be less.
Yes.
So we recalculate from the equation for mass fracture minus mud weight down, so the mass is up now.
Yes.
So the value for mass will change now.
Yes.
When the gas is coming inside the shoe.
Yes.
So it will increase.
Yes.
So we will not be able to reach our casing pressure to the mass also.
Yes.
Understand?
Yes. Understand.
Or you need to repeat. This is critical point.
The last sentence, Mr. Hani, you said what the casing the mass will not reach the casing pressure. You said.
Yeah, the mass value will increase from the initial mass value.
Yes.
When the gas is coming inside the shoe. So the mass value is increasing. So we still have range from our casing pressure to reach the new value for the mass.
Yes.
For example, imagine the mass value was 500 psi, 1000
Okay.
psi. And after the gas is
Yes.
coming inside, it will be 1200. So our margin now,
Okay.
it will be more with 200 psi.
Yes.
You will not reach the mass value.
Okay.
Even you reach,
Okay. Yes.
your show pressure will not affect because it will be constant now. Value.
Yes, because it's already in the casing. Understood.
Okay. So again, pressure at any point above, and after the gas is coming inside the show and up inside the casing, what will happen to the casing pressure? It start to increasing because the gas start
Yes.
continue expanding.
Yes.
So pressure at any point above the gas will be increasing.
Yes.
Passes, pressure will start to drop. Past, it will be constant.
Constant. Yeah.
Clear?
Clear.
Okay. Here, what is the maximum show pressure? We said with the gas, it will be in two situations. At the initial shut-in, and when the top of the gas or influx reaches to the casing show. It is the maximum expansion in open hole. With oil or water, at initial shut-in, and when the pressure change due to annular size changing, that means the influx come in narrow area, so hydrostatic head increase, so the casing pressure start to fluctuate according to the change in the hydrostatic head. This only the change you can see when you circulate oil or water out. It will be more easy because no expansion. If shut-in casing pressure exceeds mass at initial shut-in, the formation will break down as a show.
Yes.
What is the behavior for gas in water and oil-based mud? Water-based mud and oil-based mud. If you take 10 parallel influx in each case, which pressure for shut-in casing pressure will be higher? In oil-based or water-based?
Water-based mud.
Water-based, because from beginning 10 parallel it will be separate, is not dissolved in the oil-based mud.
Yes, correct.
But here it will be inside the solution.
Yes, correct.
So this is the second point. It will make the detection for the kick is more difficult if you are drilling with oil-based mud.
Yes, correct.
So first point we said in low permeability zone for the build-up trend. And second point, if you are drilling with oil-based mud. Because in oil-based mud, 6 parallel will be dissolved and 3 parallel, it will be separate. So the gas expansion from beginning, it will not show the true expansion. Till you reach bubble point. There is bubble point according to each type for gas. Normally it is near to the surface in most cases. So at this moment you will see the gas is coming out in separate bubbles out from the solution. At that moment, casing pressure will start dramatically to increase, jumping one time. That's why dealing with oil-based mud is more difficult than water-based mud if you are killing the well with gas influx.
Yes.
Okay?
Yep.
Look here at this figure.
Yes.
The left one is water-based mud. We'll start at 10,000. At 5,000, 6 barrel gas expansion. Here we take 3 barrel. Then the expansion start in constant way till to reach to the surface. Here, 0 expansion till 1,500 almost. Then 100% expansion after you reach to the bubble point. This is the dangerous with oil-based mud. That's why from beginning we deal with any type for influx as a gas kick worst scenario.
Yes.
Because you may working with oil-based mud, and you cannot
Yes.
see the expansion or shutting casing pressure will be affected from the beginning.
Correct.
Look at this example.
Correct. Hydrocarbon gas. No. It's
Should
more
be-
soluble in. So it's false.
Yeah.
Hydrocarbon is more soluble in oil-based mud, not water-based
Yeah.
mud. So B,
Okay.
false.
Yeah.
Yeah.
Do you have any question to this point?
No.
Okay. We finished day number 1, actually.
Okay. Okay.
This is your homework. The rest the
Okay.
question in this section.